Next we will be discussing the problems in quality control of water supply or waters. So let us go on to the first problem. The pH of water admitted into a treatment plant was 6 in the morning. Consequent to the inflow of raw water from a different source, it changed to 8 in the next 24 hours. So initially the pH was 6, later the pH changed to 8 in the next 24 hours. Assuming linear variation in the time of hydrogen ion concentration, the time mean pH value of water over this 24-hour period is. That is, here they are saying initially the pH of the water was 6 in morning. Later on the water was taken from a different source and its pH was 8. So, assuming linear variation in the time of hydrogen ion concentration, we are assuming that the hydrogen ion concentration is varying linearly. This is the hydrogen ion concentration and this is the time with which it varies. So the initial value of pH was 6 and after 24 hours the pH became 8. Now, the writing in terms of hydrogen ion concentration. So here we are supposed to find out the mean pH value of the water over this 24-hour period. So there is pH of water of pH 6 and water of pH 8 present in the treatment plant. So in order to find out that, initially the pH was 6. So the hydrogen ion concentration is negative log H plus equal to 6. It can also be written as H plus ion concentration is equal to 10 raised to minus 6. That is the first hydrogen ion concentration. Similarly, the second hydrogen ion concentration can be written as H2 of H initial, H final. After some time, the next pH level was this. So since we are assuming that the hydrogen concentration is varying linearly, in order to find the mean pH value, we can find out the average of these two. That is, we are finding out the average of these two. This is only because it is given in the question as linear variation of H plus is occurring with respect to time. So 10 raised to minus 6 plus 10 raised to minus 8 divided by 2. Now here, since 10 raised to 6 we are taking common out, it becomes 1 plus 10 raised to minus 2. The whole divided by 2. Now 10 raised to minus 2 can be written as 1 by 10 or 1 by 100, which is equal to 0.01. So this is 1 plus 0.01, you will get it as 1.01 into 10 raised to minus 6 whole divided by 2. We get the answer as 0.5 into 10 raised to minus 6. Now this is only the hydrogen ion concentration or the average hydrogen ion concentration. Now we are supposed to find out the mean of the pH. That is, we have to find negative log of this concentration. That is negative log 0.505 into 10 raised to minus 6. Now we have studied that log mn is equal to log m plus log n. That is why we are splitting it as log 10, log to the base 10 0.505 plus log 10 raised to minus negative log. The second term, how it came 6 is that it is negative log to the base 10 raised to minus 6. So that can be written as, this whole thing can be written as plus 6. So then we have to find out this value and we get the answer as 6.2967. That is the mean of the pH. So that is that problem. Now the next question, methanoglobinemia or the blue baby syndrome is caused by consuming water containing excess of A. fluoride, B. phosphate, C. nitrate and D. nitrite. Methemoglobinemia disease is caused by nitrates. It's very important. Always it's asked. The next question. Hardness of water is caused by the presence of which of the following in water? Chlorides and sulfates, calcium and magnesium, nitrites and nitrates, sodium and potassium. We have studied that hardness is caused by divalent metal cations. So here the hardness is caused. So here this calcium and magnesium both are divalent metallic cations which are responsible for causing hardness in water. So the answer is B. Now a rapid test to indicate the intensity of pollution in river water is A. Biochemical oxygen demand, B. Dissolved oxygen, C. MPN, and D is total dissolved solids. So out of all these, the one test which we can do quickly is the total dissolved solids test. This is because all of these are the various tests that can be conducted in order to determine the intensity of pollution, like how much BOD or oxygen is present or how much oxygen has been consumed. By looking at how much oxygen that has been consumed, we can determine how much polluted the water is. Like more is the BOD, that means more polluted the water is. And if it's dissolved oxygen, more is the amount of oxygen that is present in the sewage, that means lesser is the pollution or more good the water is. So that is one method of determining whether the water is polluted or not. Then there is the MPN, which is the method of determining the coliform bacteria that is present in the water sample. And the last one is the total dissolved solids, which simply determines the amount of dissolved solids that are present in the water. So when comparing with all these tests, the most common value, the rapid test which we can do to get this value is the total dissolved solids. So 4D is the answer. Next is bacteriological examination of drinking water for Escherichia coli or E. coli, which is a short form of that, is performed because they are pathogenic, causing intestinal diseases. Their presence indicates viral contamination of water. C. They are used as indicator organisms for probable presence of pathogens. D. They represent unique indicator organism for sewage pollution. So here we have studied that E. coli always are considered as indicator organisms, even though they does not harm or cause any problems, but the presence of the E. coli indicates the presence of other pathogenic bacteria in water, and hence the correct option is 5C. That is, it is used as an indicator organism for probable presence of pathogens. The next question. The temporary hardness of water is caused by A. Dissolved carbon dioxide, B. Bicarbonates and carbonates of calcium and magnesium, C. Bicarbonates of sodium and potassium, D is the carbonates of calcium and magnesium. So here the temporary hardness is said to be caused by both the bicarbonates as well as the carbonates of calcium and magnesium. So the correct option is option B. Now moving on to the next question. So the breakpoint chlorination of water involves addition of chlorine in an amount sufficient to A. React with any ammonia and readily oxidizable organic matter, B. Kill Giardia cyst, C. React with inorganic matter, D. Reduce bacterial growth in filters. So we have already studied that graph of chlorine residual versus the chlorine dose that we are adding, and we have initially there will be no residual, as entire chlorine that we add is used in oxidizing the iron and manganese present. After that it combines with ammonia and forms chloramines, and then it reaches a maximum limit. After that this chloramines is used in killing the microorganisms present, and after that whatever chlorine we apply will appear as residual chlorine. So this point was called the break point. So they are asking the breakpoint chlorination of water involves addition of chlorine in an amount sufficient to. So mainly the chlorine is added so that it does this purpose, reacting with iron and manganese, reacts with ammonia to form chloramines, and then it is used to kill microorganisms. So the option A is the correct answer. It reacts with any ammonia or readily oxidizable organic matter. So option A is the answer. Then the next question, the most important water quality parameter for domestic use of water is A. Carbonate hardness, B. Non-carbonate hardness, and C. Coliform group of organisms, and D. Chlorides. So the most important water quality parameter that has to be considered while consuming water in domestic purposes is whether any pathogenic bacteria is present, because otherwise it will cause diseases. So even though others are present, that is not that much dangerous as that of the coliform group of bacteria present. So the answer is 8C. Now, the presence of fluorides in water greater than the permissible level of 1.5 milligram per liter causes A. Cardiovascular disease, B. Methemoglobinemia, C. Hepatitis, D. Dental fluorosis. So here, presence of fluorides in excess causes dental fluorosis. Moving on to the next question. The alkalinity of water can be defined correctly in one of the following ways. First one, it is a measure of ability of water to neutralize oxygen. And B, it is a measure of ability of water to neutralize carbonates. C, it is the presence of ions in water that will neutralize hydrogen ions. And D, it is a measure of ability of water to neutralize hydroxides. So here, as I have told, alkalinity is always the ability of neutralizing hydrogen ions is said to be alkalinity. So the option C is correct. If it's in the case of acids, it's the ability to neutralize bases or hydroxides. This is alkalinity, and this is for acidity. So here the correct answer is option C. Now next is a problem. The BOD of a surface water sample is 200 milligram per liter at 20 degrees Celsius. That is the BOD LT is given as 200 milligrams per liter, and that is at 20 degrees Celsius. Now the value of reaction constant K value or KD value is given at 20 degrees Celsius as 0.2 day inverse. Now they are asking us to find the ultimate BOD, that is L naught. So that is given by the formula LT is equal to L naught into 1 minus, it can either be represented as Y5 or this is actually BOD. It can also be represented as LT or YT, etc. All these represents BOD. So the equation is LT equal to L naught into 1 minus e raised to minus KD into T. So LT is given here, and that is 200, that is given in the question, 200. Then K value is also given as KD value is given as 0.2. Now here in the question they are given it as 5-day BOD, that means 5 days, that is T value here is 5. So here T value is 5. Now LT is given, all others are given, so we can find out what is L naught by directly substituting in this formula. So we get the answer as D. Substituting this. Now the next question, MPN index is a measure of one of the following. So A, it is coliform bacteria, B, it's BOD5, C is dissolved oxygen content, D, hardness. So MPN index is the, what is meant by MPN index, that is the most probable number that is used to indicate the amount of coliform bacteria that is present. So the option is A, coliform bacteria. Now the next question, The microbial quality of treated piped water supplies is monitored by A. Microscopic examination, B. Plate count of heterotrophic bacteria, C. Coliform MPN test, and D is the identification of all pathogens. So what is the method we are adopting to determine the microbial quantity? That is coliform most probable number test, so that we can determine the number of bacteria that is present. The next question, excessive fluorides in drinking water cause A. Alzheimer's disease, B. mottling of teeth and embrittlement of bones, C. methemoglobinemia, and D. skin cancer. So here excess of fluorides causes mottling of teeth and embrittlement of bones. So B is the right answer. Now the next question, temporary hardness in water is caused by the presence of A. bicarbonates of calcium and magnesium, B. sulfates of calcium and magnesium, C. chlorides of calcium and magnesium, D. nitrates of calcium and magnesium. So the option here is temporary hardness is caused by bicarbonates of calcium and magnesium. Rust all is responsible for causing permanent hardness. So the correct option is A. Now, the blue baby disease or the methemoglobinemia in children is caused by the presence of excess chlorides, nitrates, fluorides, lead. It is excess nitrates. So 16B is the answer. Next, standard 5-day BOD of a waste water sample is nearly X percentage of the ultimate BOD. That is, they are saying this BOD 5, standard BOD means BOD 5 at 20 degrees Celsius. The 5-day BOD is how much percentage of the ultimate BOD, that is L naught. So the value is 68%. So by the fifth, this means that by the 5th day of BOD treatment, the BOD that is present will be 68%, or the oxygen that is consumed or the organic matter decomposed will be 68% of the ultimate BOD value. So the option is 17C. Now the next question, two samples of water A and B have pH values 4.4 and 6.4 respectively. Then how many times the sample A is more acidic than sample B? So here the pH value is given to be 4.4, that is negative log H plus ion concentration, which we also can write as log 1 by H plus, that is equal to 4.4. Now that we can rearrange and write as 1 by H plus is equal to 10 raised to 4.4. So again bringing it to the numerator, H plus is equal to 10 raised to, H plus is brought to the numerator and this is brought to the denominator. So it becomes 1 by 10 raised to 4.4. Now bringing this 10.44 to numerator, we can write it as negative 10.44. So the hydrogen ion concentration in the first case is 10 raised to minus 4.4. In the second case, in similar way, the pH is given to be 6.4. So in similar way, we can find out H plus ion concentration in the second case is 10 raised to minus 6.4. Now dividing this is that for A samples, for sample A the hydrogen ion concentration is this, and for sample B, that is the second sample, the hydrogen ion concentration is this. So hydrogen ion concentration of B sample divided by the hydrogen ion concentration of A sample, that is 10 raised to minus 6.4 divided by 10 raised to minus 4.4. On cancelling, we get 10 raised to minus A raised to m by A raised to n is given as A raised to m minus n. So here in this question, here it is given as 10 raised to minus 6.4 divided by 10 raised to minus 4.4, that is equal to 10 raised to minus 6.4, or we can write it like 10 raised to minus 6.4. When we bring this to the numerator, it is plus 4.4. The sign changes. When you bringing this minus 4.4 up, it becomes minus 6.4 plus 4.4, that is equal to 10 raised to minus 2. So we get the answer as 10 raised to minus 2. That is 1 bringing to the denominator, it's 100 times. So the concentration of sample A, rearranging this, we can write it as concentration of A is 100 times more than the concentration of B sample. So the option is 100. C is the option. That is what is shown here in this slide. The next question. In a BOD test, 5 ml of waste is added to 295 ml of aerated pure water. The initial dissolved oxygen DO content of the diluted sample is 7.8 mg per liter. After 5 days of incubation at 20 degrees Celsius, the DO content of the sample is reduced to 4.4 mg per liter. So the BOD of the wastewater. So BOD is given by the formula initial dissolved oxygen minus final dissolved oxygen, the whole into the dilution factor. So dilution factor can be found out as dilution factor if in the question it is given as 2% dilution, then we can write the total value. Since it is a percentage, the maximum value is 100. The maximum value divided by the diluted sample. That is, so one method of finding the dilution factor. Now in the question here, it is given the 5 ml is the waste sample's volume, and 295 is of the remaining is aerated pure water. So the total volume of the entire sample is total volume of the bottle in which this BOD test is conducted is 295 plus 5 ml, that is equal to 300 ml. So another formula for finding the dilution factor is this total volume of the BOD bottle V, which is 300, divided by the volume of the sewage sample, which is here 300 divided by 5. Then DOI is given here as initial dissolved oxygen is 7.8 and the final dissolved oxygen value is given as this. So, and the dilution factor is 300 by 5, this value. So substituting these, we get the answer as 204, which is option C. Now, the use of coagulants such as alum, A, results in reduction of pH of the treated water, B, results in increase in the pH of treated water, C, results in no change in the pH of the treated water, D, may cause an increase or decrease of the pH of the treated water. So here the answer is, by adding this alum and other coagulants, it results in reduction of the pH, or it will become more and more acidic as a result of addition of alum. But for the alum to work properly, there should be an alkaline environment. But the addition of alum will result in reduction of pH of the treated water. Now next question is aeration of water is done to remove A, suspended impurities, B, color, C, dissolved salts, and D, dissolved gases. Here the correct answer is option D. Aeration of the water is done in order to remove the dissolved gases. Now the following chemical is used for coagulation: ammonium chloride, aluminum chloride, aluminum sulfate and copper sulfate. So this is another name for aluminum. Alum is hydrated. Alum is nothing but hydrated aluminum sulfate, and therefore the option is option C, which is nothing but the alum. Next question. The calcium 2 plus concentration and Mg2 plus concentration of a water sample are 160 mg per liter and 40 mg per liter as their ions respectively. The total hardness of the water sample in terms of CaCO3 in milligram per liter is approximately equal to. So they are asking us to find the hardness or total hardness that is present in the water. So total hardness formula is calcium 2 plus concentration into the equivalent weight or combining weight of CaCO3 divided by equivalent weight of calcium plus magnesium 2 plus concentration in water into equivalent weight of CaCO3 divided by equivalent weight of magnesium. So here we given the calcium 2 plus ion concentration as 160, magnesium 2 plus ion concentration as 40. Now the equivalent weight of CaCO3 can be found out as, first of all, equivalent weight of CaCO3 equal to molecular weight of CaCO3 divided by the valency. Now CaCO3 means calcium, carbon and oxygen. Calcium it is 40, carbon it is 12 and oxygen is 3 molecules are there, into 16 is the atomic weight. So total, we adding all these values, we get the value as 100. So that is the molecular weight. Now this 100 divided by the valency. If you are splitting CaCO3, then it is Ca2 plus plus CO3 2 minus. So here the valency in this case is 2. So 100 divided by 2, that is the equivalent weight is 50. That is how we are getting the equivalent weight here of CaCO3 as 50 in both the cases. Now similarly, if it's in the case of calcium we know the value is for equivalent weight of calcium. In order to find the equivalent weight of calcium, molecular weight of calcium, which is 40 divided by its valency 2 plus, that we will get it as 20. So here the value will be 20. And similarly magnesium, it's 24 is the molecular weight. So similarly magnesium is 24 is the magnesium. So equivalent weight of magnesium. Magnesium is also again Mg2 plus. So valency is 2. Magnesium molecular weight is 24 by 2, that is 12. So this value is 12. So now we can rearrange this equation and write it as (160 into 50 divided by 20 plus 40 into 50 by 12. That is how we get the answer as 567, which is option D. Okay.